Hey guys, Joe again, back with another episode of the Mathematical Vortex. Today I want to talk about something a little bit different. I want to talk about uh, using working numbers and base numbers for more efficient calculations and mental math. So I guess the first thing I should talk about is that when we do math the traditional way, we tend to work from right to left, right? So if we're adding, subtracting, multiplying, we tend to work from right to left. So we have to figure out what our entire answer is before we can even start to tell you what it is, right? So I want to switch things around a little bit. I want to start working from left to right. The reason why is because when we say numbers, we don't say them like, for example, if we're talking about 635, we don't say 5 and 30 and 600, right? So why don't we try to reconstruct the way we do these things and go from left to right instead of right to left? See, then I can start telling you the answer before I even know what it actually is. All right. So the first thing I'm gonna start out pretty simple, and I'm gonna start with addition. So I'm gonna make it simple, and I'm gonna do, say, 643 plus 127. Here's how we would normally do this equation. First, we'll add 7 and 3. We get 10. Put the 0 there. Carry the 1. Now we add all those together. I still don't know what my answer is, or even what it starts with, or any of that. But here we get 2 plus 4 is 6, plus 1 is 7. And then finally, 6 plus 1 is 7. And I know my answer is 770. Okay? Here we have a working number of 1, which happens to be plus 1. So let's use that for a second. Let's do a different one. Okay? So the first thing I do is I want to start on the left. 6 plus 2 is 8, okay? But I don't want to have to backtrack and carry later. So here's how the working number works. I'm going to look at this next column, just take a quick glance, and I'm going to ask myself, does that look like it's going to be over 9? Well, sure. I don't even have to do the math to know it's going to be over 9. I can just look at it and tell, right? So since it's going to be over 9, I'm carrying a 1. What I want to do is then just go ahead and pre-carry that 1. And now I go ahead and add that together. So 6 plus 2 is 8, plus 1 is 9. And then now I can move over to the second column. So I want to just do the same thing again. Is that going to be more than 9? Well, yeah, sure, because 8's only 1 away from 9. So I don't even have to do the math yet again. So I'm going to go ahead and pre-carry that 1. And now I'm going to add 7 plus 4 is 11, plus 1 is 12. Well, I already carried my 1 to right there, right? So all I got to do is put the units digit. Bam, there it is. Now I just come over here. What's 8 plus 6? 14. I've already carried my 1, so I drop my units digit right in place, and there it is. We'll go back again one more time. I can look at it, and just by looking at it, I know that my answer is going to be 900, and I've already told you that, so I don't have to remember it, right? All done. Now I move on. I look at this units column. I know I'm going to carry a 1, so I know that I'm going to just drop the units, which is a 2, so I can now say and 20. And then I look at this last one to see that the last digit's going to be 4. And just like that, I'm telling you the answer as I go. I don't have to remember anything. Easy peasy mac and cheesy, right? All right, cool. I can also do that, though, with subtraction. We'll do 942 minus 376. Our working number is 1. then I can look here, and all I have to do to start from left to right is look just to the next column, just for a second, and make note as to whether or not my top number is higher or lower than my bottom number. In this instance, it's lower. So I already know that I'm going to be borrowing. So I'll go ahead and borrow that right off the bat. So the 9 becomes an 8, and I just subtract 8 or 3 from 8, and that gives me 500 and whatever the rest of the answer is. But I've already told you the 500, so I don't need to tell you that again. I don't need to remember it. It's done. Completely done. So now I'll move on, and I know this is 14, right? Because I borrowed the 1 already. So I look to the next column, and I see that 2 is lower than 6, and I know I'm going to borrow 1. So I'll go ahead and pre-borrow it, and that gives me 13 minus 7, which is 6. So now I know I can say 60. I already said 500, so I'm already most of the way there. So now I got 500, 60, and now I can finally work out my last digit. Well, I know I already borrowed 1. I pre-borrowed it. So this is actually 12. And now I'll just go ahead and subtract 6 from 12 to get the answer of 566. Okay? Pretty simple, right? All right. So now what I want to do is show you a little bit of, I'm going to jump ahead to 10. The way that base 10 goes, we're going to start out with numbers under 10, first of all. And the way that we're going to do that is I'm going to pick the one that seems to cause people the most trouble. We'll go with 8 times 7. Okay? Now, we're working with base 10, so we got to figure out how far each one of these numbers is from 10. So the way that we do that is we put 10 above and we subtract. 10 minus 8 is 2. 10 minus 7 is 3. All right. Now here's where it gets a little bit tricky. We got to do some cross subtraction. It doesn't matter which one you pick. They both have the same answer. See, if you go 7 minus 2, you get 5. Also, if you go 8 minus 3, you get 5. So just pick whichever one. It doesn't matter. Whichever one looks easier to you, they're going to give you the same answer. And since that answer is 5, we're going to go ahead and write that in our 10 spot. Now, the next part, all we have to do is 2 times 3, right? 2 times 3 equals 6, and that gives us our units. So easy, right? It's not even an issue, like, at all. So, what we're going to do is we'll jump back. We'll do one more example. But this time, we're going to do an example that's over 10, okay? And now this works a little bit different. Last time we cross-subtracted. That's because it was less than 10. Now, because it's more than 10, we're going to cross-add. So just like the same way, what if we do 13 times 16, right? Well, remember that our base number is 10, and 13 is 10 plus 3, right? 16 is 10 plus 6. All right. So now what we've got to do is cross add. We can either do 16 plus 3 or 13 plus 6. Either way, we get to the answer of 19. But we're working with base 10, right? So since we're working with base 10, well, that's not actually a 19. It's 190. So now, all that we have left to do is multiply 3 times 6, and that gives us 18, and we add that to our answer to get 208. Right? Pretty simple, cut and dry. So that's over 10. How about we do 8 times 17? All right. Our base again is 10. And 8 is lower than 10. So we'll go, all right, 10 minus 2 equals 8, right? 17 is over 10, so we just do that like we did last time. 10 plus 7. We cross add to one or the other. And if we add 7 to 8, we get 15. If we add negative 2 to 17, we're basically just subtracting 2, which gives us 15 also. So we have 15, but it's base 10. So it's not actually 15, it's 150. Okay? Now the next thing, we have to multiply negative 2 times 7. Whenever you multiply a negative and a positive, you get a negative. So 2 times 7 is 14. And since we're doing negative times positive, it gives us a negative 14. So we go ahead and add that, which is essentially subtracting. And that gives us an answer of 136. But what if you have 17 times 76? All right, well, let's check that out. So we have 17 times 76. You might be able to figure that out pretty easily, but I'm going to show you a way that you can use the same kind of base multiplication, but on numbers that are really far apart. So the first thing I want to do is I want to look at my 17, and I want to get it to a good tens number. Now, it's important, you want to find a number on both sides where the left side divides divides evenly into the right side. So in this case, 20 would be good and 80 would be good, right? All right, now what I got to do is figure out what times 20 equals 80. Well, 2 times 4 equals 8. So there we go. So this is what we're going to work with. 20 times 4. All right. Now we're going to go back to the 17 and we're going to look at that. Well, what do we have to do to get from 20 to 17? We have to subtract 3. Over here on the other side, we have to subtract 4. All right, so we're getting started. Now, so far so good. It's all about the same, but now we got to figure out how to split the difference, how to close that gap. All right, so the first step that we do is we come here to our working numbers, which are 20 and 4. And I'm going to just multiply 4, or my negative 3, by 4. That'll give me a negative 12. Okay. Now what I want to do is I want to cross add. But since it's a negative number, when you add a negative number to a positive number, you subtract it. So that's going to give us 64. Now, last step of that part is we have to multiply that by 20. So all we have to do really is double it, and that gives us 128. But it's not times 2, it's times 20, so we'll put our 0 there. Now, for the very last part of this, all we have to do is multiply negative 3 times negative 4. When you multiply a negative by a negative, it gives you a positive. So we get positive 12 for a grand total of 1,292. Now these are just a quick introduction to it. You know, for addition, subtraction, multiplication, but there's good news. We can also use working numbers to divide. I want to divide 130,816 by 28. Okay, so we're going to use base division with working number. Okay, so the way that this works is I want to get this 28 to the nearest tens. The nearest tens is 30. What I have to do to get to that 30 from 28 is add 2. So that means that my working number is positive 2. Okay? Now, since we're doing base division, we can just get rid of this 0, and we're going to rewrite the equation. It's going to be 3 into 130,816. All right. Firstly, 3 doesn't go into 1. So we're going to carry that 1 over and to the next digit, and that's going to give us 13. 3 goes into 13 4 times with a remainder of 1. So we're going to carry that 1, and that makes the 0 next to that a 10. Okay, but we're not dividing into 10. We have to remember that we have a working number and that we modified some stuff, and we're going to use this working number now. We're going to use this 4 here that we just got, and we're going to multiply it by our working number. So 2 times 4 is 8. And now we add that to the 10, which turns our 10 into 18. 3 goes into 18 6 times with no remainder. We got to remember, again, to multiply this 6 by our working number. That gives us 12. Okay? So 12 plus 8 is 20. 3 goes into 20 6 times. 6 times 3 is 18, so that leaves us a remainder of 2. We'll go ahead and carry that 2 over here, and that gives us 21. But we got to go back to our working number and multiply our last digit, which was another 6, by 2, which gives us another 12. So that turns 21 into 33. And 3 goes into 33 11 times. But we only have one space, so we're going to use our units. What's going to happen is we're going to carry the other one over to our 6. But when we use, now we move on and we find our remainder. Okay? So we got this, and we have 6. The last digit is a 6, and that's going to tell us our remainder. But we have to remember to use our working number. Now here's why it's important to remember that this is 11, not 1, because you have to multiply the working number by 11. Okay? That's going to give us 22. Now, here's the thing. 22 plus 6 is 28. And if we refer back to our original number that we were dividing by, our original divisor, it was 28. And 28 goes into 28 exactly 1 time. Okay? But this was our remainder. It made a full whole number, so we got to carry it over our 1. Now, if we just add all that up, we get 4,672. And that's your answer. So working numbers and base numbers are an awesome tool. I really highly recommend. Give it a chance to work, and I'm pretty sure you're never going to go back to the old way ever again. Like I said before, this is just a review. I think I'm going to do videos on each one. I just wanted to introduce you to this idea. So I think I'm going to do one for addition and subtraction. I'm going to do one for multiplication, and I'll do a whole one for division. If you're new here, make sure you click that subscribe button. If you found this video interesting, definitely give me a like. And if you're interested in more content, you gotta go ahead and smash that notification button so you get notified when I upload new videos or go live. Anyway, thanks for watching, guys. I really appreciate it. I guess I'll catch you on the flip side. In the meantime, remember to think outside the box.